Click on that thing. You're going to put on password. Only join Zoom. Hello, David. How are you?
Oh, fine.
How was
sir?
Okay.
You were talking to me, Jay.
Okay. So, David, who is there with you again?
David and David.
Okay. What of Marilyn and Marigold? They are supposed to be part of your class.
So shall I call Elijah and tell him?
They need to be part of this class. You can go back to. You can be switching between the two. So after the introduction, we'll play the video. Huh? Yeah, Sunday. I just give them like tomorrow by 4 p.m. 4 p.m.
Tí a sẹ́mi tí nǹkan tó bá ti kọjá táìmù ẹni ò ní lè submit mi.
Then tell them to check some other YouTube videos about number sense, prime factors, and ACF and LCM. Share the link. Share the link of videos on YouTube, number sense, prime factors, ACF. Hello, David. Hello, David. Can we start now? I think they will join us.
Okay, sir.
Okay. So let's start. So we want to look at number sense. So that's one of the topics in your curriculum, and that you also be treating this summer term. So number sense. So we are going to be focusing on the prime factors and ACF. Of course, I've defined mathematics for you as the study of numbers or science of numbers. Science of numbers. And example of numbers, we have different types of numbers in mathematics. We have prime numbers. We have rational numbers. We have rational numbers. So irrational numbers. So there are different types of numbers. So, but we are going to be focusing on prime number factors. So prime factors are factors of a number which are prime numbers. So prime factors are factors of a number which are prime numbers. And the example of prime numbers. Prime numbers, we have 2. 2 is a prime number. 3 is a prime number. 5 is a prime number. 7 is a prime number. 11 is a prime number. 13 is a prime number. 17 is prime number. 19 is prime number, etc. So prime numbers are numbers that can only be divided by 1 and itself. So prime numbers can only be divided by 1 and itself. That's why 1 is not an example of a prime number, because a prime number has only 2 numbers that can divide it, 1 and itself. So 1 is not a prime number, but the lowest prime number is 2. And we have it like this. So we are going to look at a short video on prime numbers or prime factorization to just introduce us to prime factorization, to have an idea of it. Then we take some few examples and then we look at HCF. So we are going to take that videos now. So can we share the video? So we'll take the video shortly now to introduce us to prime factorization and how to break big numbers down into prime numbers. Okay. The audio.
Using short division. This is the fastest method I know of finding all the prime factors of any given number. You'll see why it's great. Remember, the first primes are 2, 3, 5, 7, 11, 13 and 17. When we do a prime factorization with division, we can only choose prime numbers as our divisors. I'm going to do the prime factorization of 252. This number is not in any multiplication tables that we know, so the only thing we have to go on is that we know this number is divisible by 2 because it's an even number. So 252 divided by 2. So that we can work down the page, we flip the workspace. So now we put our answer underneath. All okay? Great. 2's into 2. 1 2 is 2. 2's into 5. 2 2's are 4 with a remainder of 1. 2's into 12. 6 2's are 12. And now we set out a new division problem using our first answer of 126. And we keep on going, dividing by suitable prime numbers until we get to the answer of 1. 126 is an even number, so I use 2 as our prime divisor. 2's into 12. 6 2's are 12. 2's into 6. 3 2's are 6. Now we work with 63. This is divisible by 3. 3's into 6. 2 3's are 6. 3's into 3. 1 3 is 3. And 21 is also divisible by 3. It's in the 3 times table. 7 threes are 21. 7 is a prime number. 7's into 7, 1. We're finished when we get to the answer of 1. All these divisors are our prime factors, so we gather them up and list them in order from smallest to largest. 2 times 2 times 3 times 3 times 7. And if we want full marks, we show the repeated factors using exponential notation. We have 2 2's, so that's 2 to the power 2.
Recording in progress.
Times 3 to the power 2, because 3 is used twice, times 7. And that's all there is to it. You can see this is another great reason to be able to do short division. When we're presented with large numbers that are not in any tables that we know, the only way to get to the factors is through division. You really have to be able to spot the divisors that will work, and this means you need to know the division rules for 2, 3, and 5 at the very least. If you know your tables, you can also spot a number that is divisible by 7 or 11. If this is dodgy territory for you, review it. Learn your tables and make yourself math strong. It will give you confidence. If this film helped you, please let me know with a thumbs up. Thanks.
So, welcome back from that video session introducing prime factorization to us. So, we have said prime factors are factors of a number which are prime numbers. And it is important to understand prime numbers. Prime numbers can only be divided by itself and 1. So the smallest prime number is 2, and we have many other prime numbers like 3, 5, 7, 11, 13, 17, 19, etc. So we want to look at an example. Express 15,288 as a product of prime factors. Now that we know example of prime numbers, so to do that, so we are going to write out the numbers that we have been given, 15,288. I'm starting with a big number so that you can see different prime factors that you can use to divide a big number. So this 15,288, since its last digit is an even number, so that means it's divisible by 2. 2 can divide it. So if we use 2 to divide this, so we start from here. 2 can go in 15, that will give us 7. Remainder 1. If we take that 1 to this, 2 can go in 12, that gives us 6. 2 can go in 8, that gives us 4. 2 can go in 8 again, that gives us 4. So looking at this, 2 can still go in this. So we are going to be using all these prime numbers to divide it until it gets to 1. 2 in 7, that will give us 3. Remainder 1. 2 in 16, that will give us 8. 2 in 4, that will give us 2. 2 in 4, it will give us 2 again. 2 can still go in it since it ends with an even number. 2 in 3, that will give us 1. Remainder 1. 2 in 18, that will give us 9. 2 in 2, that will give us 1. 2 in 2 again, it will give us 1. So we are going to use 2 cannot go here again since this ends with an even number, an odd number. So 2 cannot go here. So you check. If 2 cannot go again, you check for 3. If 3 can go. If 3 cannot go, you check for 5 or 7, 11, and like that. So let's check if 3 can go here. 3 in 19, that should give us 6. Because 3 can go in 18, that will give us 6. Remember 1. 3 in 11, that should give us 3. Remember 2 here, because the 2, if we bring the 2 here, 3 in 21, that should give us 7. So 3 can go in 1911. So then we have 637. 3
You can do 7.
can 3 go? Okay, let's use 7. 7 can go. So 7 is also a prime number and a prime factor here. 7 is 63, that will give us 9. 7 is 7, that will give us 1. That is 91. Then what number can go in 91 again? Can 7 still go?
Yes, sir.
You are sure 7 can go? 7 in 9? Yes, okay, 7 can still go. 7 in 9, that will give us 1. And then remainder 2. 7 in 21, that will give us 3. 13. So no number can go in 13 again except 13. So 13 in 13, that will give us 1. So looking at this number now, so the prime factors of this number, so if we have to write it out, that's 15,288. So that's 2 times 2 times 2. So 2 can go 3 times. Then times 3 times 7 times 7 times 13. So since 2 can go 3 times, so we can express the 2 as 2 raised to power 3. And then 3 can go only once. 7 can go twice. So that is 7 raised to power 2. And then 13. So we have been able to express this big number, 15,288, as a product of prime factors. And the prime factors are 2, 3, 7, and 13. So this is how to break a number down or express it as a product of prime factors. And later on, when we want to find HCF, highest common factors, we are also still going to need strategies like this. So you can quickly put this example down. I believe you understand it.
You're already done.
Okay, that's good. So before we move on, can I give you one to quickly do? Let me give you a number. If I ask you to break 288, express 288 as a product of prime numbers. So 288, can we quickly do that?
Sir, the answer is 2 raised to power 5 times 2 raised to power 2.
288. So you said the answer is 2 raised to power 5, Abi?
Yes, sir.
Times what?
3 raised to power 2.
3 raised to power 2, Abi?
Yes, sir.
Okay, let's confirm whether you are right. So if we have to divide.
Sir, I have a different one.
Okay, David, give me your answer.
2 raised to power 4
Okay.
times 3 times 5.
2 raised to power 4 times 3 times 5. Okay, let's see who is right among the two of you. Okay, so from 288, 2 can go. 2 in 2, that will give us 1. 2 in 8, that will give us 4. 2 in 8, 4 again. 2 can go here again. 2 in 14, that will give us 7. 2 in 4, that will give us 2. 2 can still go in 72. 2 in 7, that is 3. Remainder 1. 2 in 12, that is 6. 2 can still go here. 2 in 36, that will give us 1, 8. And 2 can still go in 18, that will give us 9. 3 can go in 9, that will give us 3. 3 in 3, that's 1. So the first answer is this. The correct answer is this. So this is wrong. So 5 cannot go here. 5 is not a prime number that we can use here. So we have 2 5 times. 1, 2, 3, 4, 5. That is 2 raised to power 5, and 3 occurred twice. So the first answer is correct. So you should learn how to break numbers down into prime factors. So you do your division correctly. So let's take note of that correction. Now I want to move you to HCF, because some of these things we are still going to take it into algebra. If not today, but at least this is the foundation for doing it in algebra. Later on, when you want to solve algebraic fractions, so we'll need it. So you can write out the correction. So let's now look at HCF. HCF is highest common factor. When you have more than 1 or 2 numbers, so highest common factors. So HCF. So when you have more than 1 or 2 numbers, let's take an example to illustrate that. For instance, example, you can be asked to find the HCF, the highest common factor of these numbers. Let's say 18, 24, and 32. So if we have a problem like this, so we have 18, so you write the numbers out, and then we have 24 and we have 32. So 18, if we look at all the prime factors of 18, 2 can go in 18, it will remain 9. So 3 can go, that will be 3 and 3, because 3 times 3 is 9, 9 times 2, that gives us 18. So these are the prime factors of 18. For 24, you also find the prime factors. 2 can go in 24, that will give us 12. 2 can go in 12 also, that will give us 6. 2 can go in 6, that will remain 3. And so the prime factors for 24 are 2 times 2 times 2 times 3. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3, that gives us 24. Then for 32, 2 can go in 32, that will give us 16. 2 in 16, that will give us 8. 2 in 8, that will give us 4. 2 in 4, that will give us 2. And then 2 in 2, that will give us 1. So 32 is the same thing as 2 raised to power 5. Now to find the highest common factor, so you just look at what is the prime factor that is common in all the three numbers. So the prime factor that is common in all the three numbers is this 2. So our HCF, therefore our HCF, that's the highest common factor, is 2. Because we have 2 here in 18, 2 can go in 18, 2 can go in 24, 2 can go in 32. But 3, even though 3 can go in 18, 3 can go in 24, 3 cannot go in 32. So it's not common to all. So the only one that is common to all is 2, and 2 is the highest common factor. So this is how to do this. I hope you understand that.
6 can go into all of them.
Yes, but 6 is not a prime factor. So you use prime factor. You know, we started by introducing prime factor. So 6 cannot go in 32. So we cannot use 6. 6 cannot go in 32. So we cannot use that. So it's 2. Let's look at another example. You can put down this example quickly. Let's look at another example.
DMV, turn on your video.
Okay. Let's look at a bigger number. Another example. Find the HCF of 280, 105, and 175. So if we have a bigger number like this, I believe we have written this.
Yes, sir.
Okay, that's good.
Alright.
So let's look at the second example here. Before I give you one to attempt. So we have these 3 numbers. Solution. We have 280, we have 105, and we have 175. So when you have numbers like this, so let's look at the prime factors for 280. So if you are comfortable with doing it like this, you may write it out somewhere so that you can get all your prime factor. 2 can go in 2, that is 1. 2 in 4. In 2 in 8, that is 4. 2 in 0, that's 40. 2 in 14, that is 7, 0. 2 in 7, that is 3. Remember 1, 10. 2 in 10, that is 5. Then 3 cannot go in 35. But 5 can go in 35. That gives us 7. 7 can now go in 7. That is it. So these are the prime factors for 280. So that's 2 times 2. 2 occur 3 times.
Turn on your video.
2 times 5 times 7. So for 105, you can also do something like that for 105. For 105, 2 cannot go in 105 because this ends with an odd number. So
Start with 5.
but 3 can go. Can we try 3? 3 can go. You start with the smallest prime numbers before. So 3 is a smaller prime number compared to 5. So you start with that. So 3 in 10, that will give us 3. Remember 1. 3 in 15, that is 5. Then 5 can go here. 5 in 35, that will give us 7. 7 here, 1. So the prime factors for 105 are 3, 5, and 7. Then for 175, let's try for 175. For 175, 2 cannot also go. Can 3 go? If we try 3.
I think we start with 5.
3 cannot also go. So let's start with 5. 5 in 17, that will give us 3. Remainder 2. 5 in 25, that is 5. Then 5 can also go again. 5 in 35, that is 7. And 7 is 7, that is 1. So the prime factors here are 5 times 5 times 7. So you look at the 3. So what will be the HCF? What will be the highest common factor?
5, and I said it from the start.
So 5 is common, Abi. So we have 5 here. 5 is here. 5 is common. 2 is not common. 3 is not also common. But 5 is common. 7 is also common.
7 is the highest actually.
So 5 and 7. So the HCF. The HCF is 5 and 7. 5 times 7.
Dude, wouldn't it be only 7?
No, not only 7. 5 is also common. You can see 5 here, you can see 5 here, you can see 5 here. You can also see 7 here, 7 here, 7 here. So the HCF are 5 times 7 or 5 and 7.
Sir,
You want to have ask a question, yes?
what if you divide numbers by the prime factor?
What if what?
Like instead of you divide the numbers by prime factor.
Okay.
Could you also find the highest common factor like that?
Yes, you can find using the prime factors. And that's what we have actually been doing. We use prime factors. The prime factors are 2, 3, 5, 7. So, but to get the HCF, after finding the prime factors of each of the number, you now look for the one that is common throughout all the numbers. So, for instance, we have 2 here, but 2 cannot go in 105, 2 cannot go in 175. So, 2 is not common. For instance, we have 3 here, 3 can go in 105, but 3 cannot go in 280. 3 cannot also go in 175, so it's not common. So it's only 5 and 7 that can go. Yes. Yes, David.
You know how 35 is like in all of them?
Yes.
7.
Yes. You can also write it as 35. So 35, you can say the HCF is 35. That is 5 times 7, 5 and 7, which is 35. So you can write it like that. Okay, so let me give you one to quickly play with now. So I want you to write this down. So I'm going to give you one to work on now. Attempts. I want you to attempt this. Find the HCF of, let me get the number, that's 288, okay, 160, 96, and 244. So find the HCF of this number, 160, 96, and 244. So you have 3 minutes to quickly do that. So let's do that. 160, 96, and 244. I want you to use this approach. Then you take a snapshot of your working, put it on the digital church WhatsApp platform. I'll check it and access it there. So you have 3 minutes. I want you to be fast with that. Okay. So show your workings. So, and look for the highest common factor.
The answer is 2.
That is
Uh,
not allowed to say.
Take a snapshot of your answer, your working. I want to see your working on the platform.
You can't tell.
Turn on your video.
I'm snapping. Calm down.
I'm expecting your answers, your workings. I'm expecting your workings. So use all the prime factors. I don't know if the class code has been given to you, but I just dropped it on the platform. The year 7 class code for this math class. So you can also take a snapshot of your working and submit it there also too in the Google Classroom. But if you don't have the class code yet, you can drop it on here.
I've only been able to do the Gorilla Science homework because I can't find the rest.
Okay. Who is Starboy Dave?
No, sir.
Okay. I'm checking your workings. Your working is wrong, oh. Your working is wrong. You didn't get it properly. You did not follow the procedure I asked you to use. I want you to follow this procedure. See the way I've done it. You will express each of the numbers like this, the prime factors. Start multiplying. Then look for the ones that are common. So do it again. Follow the steps. The way we have done the example, you will get it. Just break the number down into their prime factors. It's over 5 minutes. So I'm yet to see your workings. So don't tell me this is difficult. It's not difficult. So you need to know your multiplication table very well and your divisions to be able to do this. David, what is happening? What is happening? What is happening?
I'm almost done.
Okay. You need speed also. So the three numbers are 160, 90.
So, sir, on the thing, yeah. So I'm doing the 244, and,
Okay.
and I'm dividing it by 2, and it's 122. And then when I divide that by 2, it's 60, it's 61, and I don't know the factor for 61.
Factor for
It's
61.
the prime number.
61 will be a prime number then.
So 61, 61, 1. So yeah, and I'm done.
Yes. Oh yeah, state it out. Write all the prime factors or prime numbers. Write them out. Then look for the one that is common. If you find anyone that is common to all, so write that out. So that's how you get your highest common factor. Okay. David, where you miss this is this. 2 is common not only once, but twice in all the three numbers. So your ACF supposed to be 4, 2 times 2, not just 2 alone. So let's break this down. 2 in 160, that will give us 80. 2 in 80, that will give us 40. 2 in 40, that will give us 20. 2 in 20, that will give us 10. And 2 in 10, that will give us 5. So we have, if we break 160 down, 160, 2, 80, 40, 20, 10, and 5. So this 2 is 5 times. Then 5 times it. Then for 96, 2 in 96, 2 in 9, that is going to give us 4, remainder 1. 2 in 16, 8. 2 in 48, 24. 2 in 24, that will give us 12. 2 in 12, 6. 2 in 6, 3. 3 in 3, 1. So this is going to be 2 times 2 times 3. Who is asking question or making an observation? 1, 2, 3, 4, 5.
Save 10 on your video.
Okay. Then for 244, for
David,
240.
my dad said 10 on your video.
You said 10. Okay. Okay, yeah. 2 in 244. That's 1,
I was
2,
taking a
2,
picture and then I was skipping.
2, yeah, 6 to 1.
David, why are you putting off your video?
And then
I
6
was
1.
taking a picture, sir, and then my dad was skipping.
So that is 2 times 2 times 61. So David, so you were right with all the prime factors. And you can see that 2 is common here. 2 is also common here. So it's twice. So your HCF is now going to be 2 times 2. And that is actually 4. Because the 2 is common in all the 3 numbers twice. So if it is 3 times, that's how you write it out and you multiply and get your HCF. So, but since it is only twice, even though these 2 are common here, but not in the 3rd number, so we cannot reckon with them and the other prime factors. So, when you are looking for your HCF, make sure that your HCF, that's why it's called highest common factors. So you look for all the factors in all the numbers that you are given. So that's how to get HCF. Do you understand now? So take note of this correction. Take note of your correction. So any question, any clarification, any further clarification?
No, sir.
So I want to be sure you understand it now. Should I give you one more to attempt? Let me give you one more to attempt, because once you get it with numbers, when we get to algebra, it will be easier for you to get it right with algebra. Once you get it with numbers, it will be easier for you to get it right with algebra. So let's take one more. Let's see if you guys get it. Then I will know that you have it covered. Find the HCF of 42, 70, and 56. So find the HCF of these 3 numbers, 42, 70, and 56. I expect you to be fast with this. Within the next 2 minutes, let's see the first to get it. Take a snapshot of your working and put it on the platform.
Sir, it's 2 times 7.
Okay, so let's confirm. Let's see whether that. So we have these 3 numbers, 42. Let me see you're working on the platform. I will check it now. 6. Okay. So David Sweetie Liar. Okay. Two times. Two times 7 will give you what? You got it. 2 times 7. So 2 times 7 will give you 14. So your final answer, HCF, is what? 14. Do you get it? So you should include 14 there. So you got it. So 2 in 42, that will give you 21. 3 can go in 21, that will give you 7. So this is this. For 70, 2 in 70, that's 35. 5 can go in 35 and 7 can go in 35. Then 2 can go in 56. That will give you 28. 2 in 28. That will give you 14. 2 in 14. That will give you 7. So 2 is common. 7 is also common. So the HCF here is 2 times 7. So today we have been able to learn about part of the topic in your curriculum for this summer, which is number sense. Understanding prime factorization, prime factors, HCF. So I want you to check your email address. You see the WhatsApp platform. You see the code for your access to the Google Classroom. So you'll find the assignments you have to do there. So you can also check some other YouTube videos to understand more about prime factorization and HCF. So I hope you have been able to learn about how to break number down into prime factors and how to.
David Oluwale Dada.
Yeah. Okay.
Why is your video not on?
But he's sending a video.
So today we didn't see Marilyn and Marigold.
Elisha went out.
Yeah, they went out to them, so they were just coming back.
Okay. So the class is 1 hour. So we've just come to the end of the class. So check on the Google Classroom. Your assignment is already there. What you have to do, and you have to submit latest before 4 p.m. tomorrow. So do that, and then we are good. Later on, I told you the way we have been doing the HCF with numbers. Later on, we will take it with algebra, which is the use of letters. So if you understand it very well with numbers, how to break it down with numbers, it will be easier with letters. So take note of that. So, and have a good night rest, and make sure you do your assignments. Bye.
Bye.
Goodbye. God bless you.
David,
Yes.
God bless you.
call me on WhatsApp.
Okay.
Huh?
God bless you.
Okay, guys. Pastor, are you done?
Yes, I'm done with them.
Okay. So, sorry, we have year 8 and year 9 tomorrow again.
Yes, sir. Okay. So
I
year 8
think it was
and
the
year
dance.
9, they will be having science class.
So I think it was the dance class timing that affected us a little bit.
Yes, sir. Yes, sir.
So we needed to do the dance class, but all these things will be fine.
Yes, sir.
So all this will be done there. We continue by next week for the parents that want to have it for their children.
Okay, sir.
Thank you very much, Pastor Shola. God bless you.
Okay, sir. So, and with me, I have some of my assistants here. So,
Yeah, let's see them, please.
Esther and
Let me see them.
Israel and Esther, you can come. So this is Esther. So
And Israel.
she also participated in the dance
I saw her.
training, and then Israel. This is Israel Akafa in 100 level 2. Yeah.
100 level. Okay, what course
Yes,
are you
sir.
doing, Okuta?
Marine science.
Marine science. Oh my God. Great. Great. Yeah. Will you be in the powerhouse in the evening?
Yes, sir.
Yes. Okay. I'll be coming to your powerhouse today. Hey, Esther, how are you?
Fine, sir.
What level now?
100.
100 too, as well. That's fine.
Chemical,
How about your
chemical
exams?
engineering.
So it's fine, sir.
Are you done with exams?
No.
How many more?
1.
One more. Israel, how many more to go? 2 to go. Okay. You guys, please maximize your time very well. And we'll see you at the powerhouse. And after exam, we're having a retreat with you all. Yeah, I'm going to paint the future together from 100 level. God bless you guys.
Amen.
Amen.
Yeah, see you.
Amen. God bless you.
Mashallah, thank you for all you're
Thank
doing.
you, sir. Thank you, sir.
Yeah.
Welcome, sir.
That's true.
Well done, sir. Amazing. Amazing. So we can stop the recording. So the class is on. Let's stop the recording.
Recording stopped.